Okay, class, good morning, everyone. So, today we will be discussing about the respiratory physiology. Last time we discussed the anatomy of the respiratory. Okay, so this time we are going to know how does the respiratory system function in our body. Okay, so there are four events that are very important to know about the respiratory system. Okay, about the respiratory physiology. First is the pulmonary ventilation. Okay, pulmonary ventilation is also known as breathing. Okay, so when you ventilate, pulmo means lungs. Ventilate the lungs means you put air and put out air inside the lungs, and it's called breathing. So inhale, exhale, that's breathing. That's pulmonary ventilation. Okay. For the second event, we have the external respiration. Okay. External respiration, again, by the word external, it's exchange of gas from the blood to the environment. So gas exchange between pulmonary blood and the alveoli. Okay, as I have said before, the environment is the alveoli because the air coming from outside the environment goes inside the alveoli, and there's a gas exchange between the pulmonary blood. Okay, if you remember, the alveoli is outside the alveoli is full of capillaries. No, it's embedded with capillaries, and that is the blood. Okay, so that is the pulmonary blood. So what are the gases? Of course, we all know oxygen and carbon dioxide. These two exchanges in the alveoli and the blood. So when the blood goes in the lungs, okay, in the pulmonary capillaries, oxygen is loaded into the blood and carbon dioxide is unloaded from the blood. So that is what is happening. And if you look at here, okay, so if you look at here, this is the gas blood barrier or air blood barrier. Gas or air blood barrier. So in between the blood vessel and the alveoli, there is what we call the blood gas barrier or gas blood barrier or air blood barrier. It depends, no? So from the side of the alveoli, we have the alveolar epithelium. Okay, from the side of the capillary, we have the capillary endothelium, the lining inside, no? And the lining in the alveoli, and in between there is a fused membrane, so they fuse together here wherein gas exchange is happening. Okay, for we all know, it says here the total gas exchange surface provided by the alveolar walls of a healthy man is 50 to 70 square meters. That's very big, or that's very wide, no? It's like a basketball court, or approximately 40 times greater than the surface of the skin. So if you spread out, okay, the tissue, alveolar tissue, this is the size. Okay, so there is a wide area of gas exchange happening in the lungs. So ganun kalaki, ganun kaluwang ang gas exchange area of the lungs. Okay? Next, there will be the next event is respiratory gas transport. So since there is already gas exchange, okay, oxygen should be transported into the tissue. Okay, and carbon dioxide should be transported out from the body. Okay, so the medium of transportation is the bloodstream. Yeah. So gas travels in the bloodstream. So it enters the lungs, goes to the heart, and the heart is the one pumping the blood to circulate in the body and distribute it into the tissue. And it will go back again and go to the uh, lungs. Okay, so that is respiratory gas transport. No? And then internal respiration. If you say internal respiration, you are now talking about gas exchange between the systemic tissues cells in the systemic capillaries. Okay, there is exchange between the blood and the tissue. So, blood and tissue. In the external respiration, we are talking about alveoli and the blood. Here, blood and the tissue. Okay? That is the difference between the two. So when you talk about internal respiration, gas exchange between the between blood and tissue in the systemic capillaries. So where is the location of this? Here in the systemic capillaries. What is this systemic capillaries? We have the vein and the artery, and they connect capillary. So if we go uh, to our tissue, no, tissue and cell, no, we can find these capillaries. So there is a gas exchange in the systemic capillaries. So the process of breathing, there are mechanisms of breathing. How do we breathe? Okay, it's a mechanics of breathing. Okay, or pulmonary ventilation. So it says here, completely a mechanical process. So this is a mechanical process, no? Breathing is completely a mechanical process. Depends on the volume changes in the thoracic cavity. What is the thoracic cavity? Again, what is cavity? Cavity is space. Thoracic cavity is our chest, no? In our chest. So, space in our chest. So, completely a mechanical process that depends on the volume changes in the thoracic cavity. So, it depends on the volume changes in our chest cavity, no? Volume changes lead to pressure changes. Here, volume changes lead to pressure changes, which lead to flow of gas to equalize pressure. This is something confusing. No? It says here, volume changes lead to pressure changes. Like this, no? Okay, so air is the volume of air is determined by the shape, size of the container. So this is the container. When the air goes in, it's the volume of the air. No, that's why if there is a change in the volume, there is a change in pressure. No, so if this is the lung, when you inhale, it becomes larger. Okay, there will be volume changes from smaller to bigger volume. Okay, so the container is the size of the volume of the air. So if you inhale, the lungs expand and the volume increases. Okay? Another rule here, it will lead to pressure changes. Okay? The rule is, the greater the volume, the lesser the pressure. Okay? So if you inhale, the volume increases, the pressure decreases. Okay? That's why air will flow inside. Okay? And it equalize the pressure outside or atmospheric pressure and inside. Okay? You get it? Okay. So, gas conforms the shape and of the container and fills its container. The larger the volume, the lower the pressure. The lower the pressure, the more closer the molecules. Okay? That's what I have explained a while ago. And there are two phases of the mechanics of breathing, no? So, inspiration, you know already what is inspiration. Inhaling air, no? Flow of air into the lungs. Expiration, exhalation. Air leave the lungs. Okay? That's like inhale, exhale. That is the mechanics of breathing. There are two phases. That are the two phases. So, what is happening during inspiration? Okay, in the inspiration, what we are going to take note is this one, the diaphragm. Okay? This one is the diaphragm. No? Okay? So, the diaphragm is the muscle for breathing. Okay? It's the major muscle for breathing. Actually, there are two major muscle for breathing. We have the diaphragm and the intercostal muscle. There are muscles here that are connected to our ribs. Okay? And take note the shape of the diaphragm. It's a dome shape. Dome shape. No? It's a dome shape. So, during inspiration, what is happening? This one contract. The diaphragm muscle contract. And what will happen to the diaphragm? It moves inferiorly and flattens. Okay? So this is the one thing that we should know. That when the diaphragm is relaxed, the diaphragm is dome shape. So it is a dome shape like this. No? But during inspiration, it contracts and it flattens out. Okay? It's depressed. So this one will flatten. It will become flat. Okay? Take note, the superior and inferior dimension. So here, the superior dimension and the inferior dimension of the thoracic cavity increases. Okay? Because when this one flattens, okay, so the diaphragm goes down, okay, increasing now the size of the thoracic cavity. Okay? So increasing now the thoracic cavity. So there will be a greater space for the lungs to expand during inspiration. Okay, let's sum up. During inspiration, the diaphragm contracts, okay, and it flattens out, and the superior and inferior dimension of the thoracic cavity increases. The lung expansion will be easier and greater. Okay, so another structure here is the external intercostal muscle. So this is the next muscle. No? Okay, so during inspiration, again, take note the word contract. Okay, so this external intercostal muscle will contract and the size of the thoracic cavity increases. How? When it contracts, it pulls the ribs up. Okay, it pulls the ribs up. So it will pull the ribs up. Okay, and then it will increase the diameter of your rib cage. Okay, what will happen if this one contract? Okay, the size of the thoracic cavity increases. Okay, so external air is pulled into the lungs due to the increased intrapulmonary volume. Oh, look at this one, intrapulmonary volume. Okay, so when the ribs is pulled up, this diameter increases. No? So the thoracic cavity increases and at the same time the diaphragm flattens. So this area will increase and it will increase intrapulmonary volume and decrease in gas pressure. So the greater the volume, the lesser the pressure. The air now can go in. Okay? So to summarize, during inspiration, diaphragm and intercostal muscle contract. Remember contract. Okay? Diaphragm flattens, external intercostal muscle pulls the rib, the size of the thoracic cavity now increases, and the external air is pulled into the lungs due to the increase in intrapulmonary volume and decrease in gas pressure. So again, the theory, uh, if the volume increases, the pressure decreases. Air will go in. That is inspiration. Okay? Okay, let us see the illustration here. No? So here, the intercostal muscle contract, raising the ribs, elevating the ribs. No? Now, what will happen? What will happen is this one, the anterior posterior. So what do you mean by anterior? The front and the back dimension increases. No? Increasing the diameter of the thoracic cavity. Okay? So that is the external intercostal muscle. Okay? And at the same time, diaphragms move inferiorly during contraction or it flattens. Look at the diaphragm here, it flattens. So the superior, so what happened? The superior and inferior dimension increases in height. So increasing the thoracic cavity. So the volume, intrapulmonary volume increases. Okay? The intrapulmonary pressure decreases, air will now go in. Okay? So here, in the tidal volume, so we have pressure during inspiration. Intrapulmonary pressure decreases, okay, until it equalizes to the atmospheric pressure. And during expiration, intrapulmonary pressure increases until it equalizes. Okay? So the volume of breath would be like this. Okay? 500 ml. So 0.5 ml in one breath. And that is our tidal volume. Did we get it? Okay, that is our tidal volume. Okay, let's move now in expiration, the second mechanics of breathing. Expiration is in exhaling air out from the lungs. Okay, and this is, take note, passive process. Okay, it automatically exhale. Okay, so there's no contraction of muscle here. Okay, there's no aid here. There's no contraction of muscle. That's why it's called passive process, which depends on the natural lung elasticity. Okay, and we all know that the lung tissue is made up of elastic, connective elastic fiber. No, what do we mean by elastic? Okay, if you say elastic, they have the ability to stretch. Not only to stretch, but they have the ability to recoil. Okay, so they have the ability to stretch, but they have the ability to come back, which is recoil. Okay, expand and recoil. Okay, that is the characteristic of the lung tissue. So when you inhale, exhalation is a passive process. There's no help from the diaphragm and the intercostal muscle. Okay, they just relax, and because of the lung elasticity, expiration will happen. Okay? Take note, passive process depends on the lung elasticity. Okay? As muscles relax, what are the two muscles again? Diaphragm and external intercostal muscle are pulled push out of the lungs due to decreased intrapulmonary volume. So the volume will decrease, the pressure inside will increase. Okay, exhaling the gas. Okay, so increase in gas pressure. Force, okay, so that one, no? So forced expiration can occur mostly by contracting intercostal muscles to depress the rib cage. So if you want to force, no, what you will do is to make the internal intercostal muscle to contract. Okay, that could happen, no? So here, if you want to force it, you use your internal intercostal muscle. Okay, remember, in the mechanics of breathing, we are only talking about two muscles. We have the diaphragm and the external intercostal muscle. Don't be confused with the internal intercostal muscles, because this one is only used if you force your expiration. Okay? Okay, so what happens here, no? So when the ribs, so when the ribs is depressed as the external intercostal muscle relax, okay, so this anterior posterior, okay, will decrease, And also, when the diaphragm muscle moves superiorly as it relaxes or it becomes dome shape again, okay, this one also will decrease, causing now an increase in intrapulmonary pressure, decreasing the volume, and exhalation will happen. Okay, so let's see. During inspiration, pressure decreases. In expiration, pressure increases, air goes out. Here, air goes in, air goes out. Okay, volume increases, volume decreases. Okay, that's the mechanics. So, okay, pressure differences in the thoracic cavity. So, this is very important to know also, the pressure differences in the thoracic cavity. Okay, pressure differences in the thoracic cavity. Normal pressure within the pleural space is always negative. Okay, it is called intrapleural pressure. Okay, so did you remember the lungs? The lungs, there is a covering of the lung. For example, this is the lung. The lung is covered with serosa. The serosa is called pleura. Okay, the serosa is called pleura, and this is two layer. No? Here, parietal pleura, and here is the visceral pleura, which is attached to the lungs. And the space is called, in between them, there is a space. This is now called the pleural space. Okay, and the pressure here is always negative. Negative 4 to 0. Okay, so it's negative. So always maintain this one negative. Okay, so that's the difference on the thoracic cavity. Okay, so one is the pleural space is always negative pressure. Okay, so there are conditions that happens, or if there are diseases that make this one positive. Sometimes if you have pneumonia and your pneumonia is untreated, you develop pulmonary effusion, meaning there is a leak from the lungs. The fluid goes to your pleural space, okay, and accumulate inside the pleural space. Since this is negative, once foreign bodies get in to your pleural space, it becomes positive. Okay? So what they will do is they will create a hole here called CTT, chest tube thoracotomy, and drain the fluid outside. Later on, if you will have your duty, you will see some patients with tube in their chest. Okay? Another one is when air goes inside. Remember, cavities are spaces without air. Okay? When you experience stab wound, no? When a stab wound in your chest, do not remove. Okay? So, if the knife is stuck here, do not remove it, because once you remove it, air will go inside, and this one will create a positive pressure. Okay? Positive pressure is very dangerous because it will collapse your lungs. Collapse of the lungs is called atelectasis. So it will collapse the lungs, you will die. Okay? There is what we call pneumothorax. Pneumothorax is presence of air in the lungs. But if it is abrupt, it's called tension pneumothorax. You just count 1, 2, 3, 4, 5, 6, 10 seconds, you will die. Okay, you will immediately die. That's why if you have a stab wound in the chest, do not remove the foreign body so that you will live. Okay, and until you reach the hospital. Okay, clear? So this one should always be a negative pressure. Okay. So differences in the lungs and the pleural space pressure keeps the lungs from collapsing. Okay, that is what is happening. Always take note that the pleural space should always be negative. Okay. So this is an example of the X-ray of our lung. No? So if you have the X-ray of your lung, actually you cannot see the lungs. That is why clear. No. So these structures are our heart, okay, our stomach. The lungs is a little bit visible. So this is the lung, no, here. Okay, but if you have so many, just like cobwebs that you can see, there is a problem in your lungs. But usually, what you can see in the X-ray is like this. It is clear. And if you have fluid here, the fluid inside your pleural cavity, you can see dark here, dark. It means there is fluid. What they do is they put a hole in the fourth intercostal space. So this is the first, second, third, fourth, or fifth. Okay, so they will put a hole here to drain it. Okay, drain the fluid, excess fluid inside. But if it is tension pneumothorax, for example, you have an accident. Okay, so if emergency cases, what will you do is, because it is air, it goes up. Put a hole here near the apex of the lungs. So air will go out and you will live. Okay? So there are also non-respiratory air movements that can go inside the lungs. So air can go inside the lungs through cough, sneeze, okay? So this one clears the lungs of debris, okay? Crying, emotionally induced mechanism also. When you cry, you inhale, you exhale. Laughing also similar to crying, hiccup, and yawning. Okay.